afternoon today to our next webinar. Today we are going to talk about SMB, or maybe old name was the CIFS, and the active high available storage cluster with Jovian open, of course. So our agenda for today, first the short introduction to charts, how the cluster should be built. So we have a few options here. Then we are going to show the demonstration environment, and we will demonstrate the live failover with I was taken just Excel here, Robocopy copying all the files, and of course iSCSI data store, because everything is in a virtual environment, and Jovian is working as a virtual storage appliance cluster, HA cluster. So additionally to my SMB failover, I will also demonstrate VMware failover. And because we very seldom talk about the duplication, so a few short demo about the duplication as well. So let us go also to the chart which I'm showing every time. The Jovian is very rich in features, and we have sorted this like for the data integrity, protection, optimization, acceleration, availability, accessibility, and virtualization. So on every side we have addressed the problem, because storage from one side looks like very simple stuff, but when we go into details and we want different features, so it can be complicated. Today we will touch, as I mentioned, the duplication, high availability, and access via SMB or iSCSI, right? So let us go to the typical cluster setups. The most easy, and we have comparison with our DSS v7 just for better understanding. So the very first possible choice, you will have 2 cluster nodes and a shared JBOD, right? Of course you can have one or more JBODs. Both cluster nodes are having a SAS HBA inside, and in the JBOD you need to have SAS disks inside, so doesn't matter if this is SSD or hard disk, everything needs to be SAS, right? On DSS v7 side, it was no such a requirement, because here we have a DRBD replicated storage, right? And in this case we use a so-called shared storage. So next option, if we are using SAS connection, so between 2 nodes, we can mirror both sides, right? So every disk on the left side will have a mirror on the right side. In this case, there is no way to use a Z1 for parity or Z2. You will have only mirrors, and mirror will also work over the SAS interface, right? Next option is kind of cluster in box. So if we want to make it very simple and do not use so many boxes, so it is possible to make everything in one box. Of course we can add more disks with external JBODs optionally. So here we have also mirror situation on the Jovian, that every disk will be mirrored to another one. Here we have next to mirrors, we could also use the, because it's a shared backplane, we could also use Z1 or Z2, Z3. So this situation is almost identical to the very first one. So I will switch to the very first one. Okay, that we have 2 nodes and a shared backplane. So I coming back to the clustering box. Here there is also situation we have a shared backplane and the 2 nodes within one box. So we can have mirrors, as I mentioned. We can have in this case Z1s, so the single parity data groups, or Z2, Z3. We have tested this with Supermicro SBB, and the next one is AIC. SBB is already in our hardware compatibility list on the certified server on our website. One more option for Metro cluster, if you want to have a cluster over 2 buildings, then we have tested and certified ATO fiber channel switches. So that's the SAS fiber channel converter switch. This works perfect, and you can use a very long distance between both, I guess 50 kilometers or something like this. Okay, next option is a bit different. Now the disks are in the host, are in the node, not like let's say on the first one, or here when we having a node and the JBOD external. Here on our slide number 8, the server has a disk inside. In order to make it possible that the disks can be found by both servers from both, we need SAS expanders. Because HBA can import disk from the external box, but cannot export. In order to export the disk, we use SAS expander. So in the left side you will have a HBA plus SAS expander, and on the right side you will have also HBA and SAS expander. So this option is also possible. Also you can expand with more JBODs. This cluster is still SAS cluster, means something like 10 meters distance, so 2 racks, because all these connections is SAS only. Next one, we are just finalizing a solution which, instead of SAS for mirroring, we will use Ethernet. In this case, this will be already in Metro cluster. Good news is that here there will be not a must of using SAS disks, right? So very good, because SAS SSDs are quite expensive. Also, there is a problem with devices like NVMe and so on. Here we will have no more this limitation to SAS. That will be great news when we just release it. Okay. And now I want to also show few options which you can configure a cluster, and I was already showing such a chart a few months ago, but here on the SAS HBA it was a single connection, so every single JBOD could have just a single cable to the node. Now actually today is a big day, because we are releasing the version Jovian update 18, which has a disk multipath inside. So here we when we have a JBODs with a dual expanders, we can already make a multipath, disk multipath from the Jovian to the external disk, or even internal disk if this is in the internal JBOD, internal backplane, right? And the concept of the cluster is a ring which is used for detection or heartbeating, detection of the failure of the other nodes. So here we have the active backup bonding. That's by design. We need a redundant ring connection, so all these heartbeat signals are going over the redundant active backup bond, and also ping signals are sent to these. Ping nodes are external, so they are in our storage client, right? So here I have a 2 storage client, and of course everyone has at least one ping configured, so we are pinging both, right? So ping and ring heartbeat, that's the cluster monitoring. And next adapters can be used for storage export. So here we have in this situation also active backup bond for the storage export, but we can also use some other bond methods. and because of the bond I can use a single virtual IP, because the bond is appearing as a one logical interface. So this virtual IP, which is used to export our resources, and the switching IP, swapping between both cluster nodes, will be just a single virtual IP here. Okay, next option, everything is identical. Instead of this export, storage export is now on multipath. So I do not have bond here, I have a two separate paths, so I will have also two separate virtual IPs. And on the storage client, I also use the two cards on the separate subnet to access our, to configure a multipath, right? And on this chart also I use a double connection to show that now disk multipath is possible as well. Next one, here we have the iSCSI MPIOs. So here I was having a 0 single point of failure, two switches. Here I have also two switches, single point of failure, but the difference is very, very thin, you know, just a single JBOD. So here I was having two JBODs with option to mirror disk each other, and the next one, of course, I can just use a single shared JBOD, and I will not mirror disk over two JBODs. I can mirror these groups within these JBODs, or I am also free to make a Z1, Z2, Z3 parities on this. Of course, I can have more JBODs as well. The network topology is identical as before, so I have iSCSI MPIO. Okay, next option, so such a iSCSI MPIO I can use on two paths which are bonding itself, right? So in this case, I can have a iSCSI MPIO. I can use MPIO for iSCSI, maybe as bond connections for redundant NFS or SMB. So everything is possible. If I don't have 10 giga, but I have plenty 1 giga, so I could use also this kind of setup. And that will be logically almost identical as a previous situation here. But the only difference is that instead of single path over the on the single path, just a physical path, I will have a bonding, right? So that's the case, that's the difference here. And one more chart. The difference here is that the VMware and Jovian is running on the same machine. I will come back. So here you see I have a Jovian running on the node, and the ASX is just on the separate machine or some other virtualization, right? Hyper-V or Xen. And on the last chart, I'm showing Jovian running as a virtual machine, so virtual storage appliance under VMware. So this will be very thin installation. Of course, everything will be done also in cluster in the box. So you can have the virtualization, so hyper-convert virtualization plus storage, everything, and high availability, everything in one box. So this is possible. In this case, I'm using a single path, so not using a SAS multipath, and that's exactly the today setup which I'm going to present. So everything is prepared for the iSCSI and for the hyper-converged environment for the VMware, but we are going to talk about SMB today, right? Yes. So one of the Windows machine which I will be accessing will be also accessing SMB over one of the path. Yes, this is possible. So I will not have the path redundancy of my Windows clients, and I'm able to access first or second path because I'm also connected to the switch. Okay. So now let us switch to our demo environment. So as I mentioned, we have a 6 here, and I go to the center. We have a HA cluster installed on the, and I have two AS6 nodes, so 030, 040, two AS6 nodes, and two Jovian. So the Jovian 32 is working on the node .30, and the next Jovian .42 is working on the node .40, right? And these Jovians are not movable because they have pass-through controller. So I was installing on both Jovian. There is a on the first one I have a LSI Logic HBA, and on the second one I have a I need to go to configuration, advanced settings. I have an Adaptec HBA. So this is to demonstrate that both LSI and Adaptec can go as a pass-through device, right? So the servers are not identical, but we can see that the Adaptec is configured here, and the second Jovian is getting this device edit settings, this Adaptec HBA as a private device. So that's the device which is pass through to this virtual storage appliance. And the first one is having LSI Logic, right? So that's the difference between both nodes. And both nodes, I will show you the network configuration. Okay, so as you see, we have a first is a management and vMotion and so on. So I need redundant network for the cluster, for the virtualization cluster. And here we have two nodes, two network interfaces to import our iSCSI. So iSCSI is exported from Jovians as a multipath over two different paths. Now, coming back to our iSCSI setup, so we have two paths on the first server, and the second one, believe me, is identical. So we have also redundant path on our management network, and we have here two paths to access to the iSCSI. Okay, when I go to the storage adapters, then you see there will be in properties, we have 2100 and 3100, both adapters are connected. And the same story on the second one. When I go to manage path, then you see I have a two path. Of course, instead of fixed, I can just make a round robin. Okay, so two paths are active. Same story here. Round robin can be used here. That will okay. That's better setup. So 2131, both paths are active, and my Jovian, it is exporting. That's my Jovian cluster 3242, both nodes, and we have two pools. So pool 0 is on the 32 active, and the pool 1 is on the second one, right? So on the pool 0, I have one iSCSI target with two volumes. So in normal cases, we will mostly have one iSCSI target per every volume, but here I have one target and two volumes, and both two volumes are exported to our VMware, and we have both here. Okay, so we have a created iSCSI failover cluster as a virtual storage appliance in our both VMware 6 nodes. Okay, and what I'm running here, not a lot. I'm just running this vCenter, which I'm connecting to this. So you see when I go to the vCenter, so that's 0236. That's exactly the one which I'm connecting. And there is one more Windows MS SQL machine with 0246, right? So I do not run a lot here. Where is my SMB client? My SMB client is this Windows which I'm accessing right now. And where is my SMB export? Okay, so let us go to our Jovian. So that was iSCSI target, which is dealing with as a HA cluster for VMware. And when I go to shares on pool 0 as well, I have a data set. So that's the data set. Share name is data. And interesting stuff, the duplication is on now, okay? Because we are going also to touch the duplication a little today. So this volume is active, so I have a running cluster. I'm connected, so let me make it smaller. Okay, so we have two pools, pool 0, pool 1. Pool 0 is active on the first node, and we see the next pool is active on another node, right? And we have here also a script. That's the script which will be writing in the loop to our MS SQL, right? So that's the script, and I can show you that the script is running all the time in loop and is writing to this Windows MS SQL, right? There is one more stuff. I have a, maybe I will show you, I have a script which is type. Okay, so that's the very simple script, a loop batch script, which is just deleting everything on my test folder and then copy. So you see, I have a share. I was mounting a share from the 192.168.2100, so it's exactly same path used for iSCSI. I was mounting this share over SMB, right? I have a book, that's the Excel file, which is stored here, right? So I can maybe delete something and save it, right? So I have a this Excel file working here. We will be copying all these files, and then while copying all these files, we will be trying to make a failover. So now I was removing the second directory. Let me run this file. Okay, so that's the, I was running wrong. Aha, sorry, I'm running no. So first I'm copying a big file, 2.7 giga. Okay, and then there will be thousands of different files copying all the time. So that's the first test which is running. Second test, that's the MS SQL, which is writing to the Windows machine, which is as a virtual machine in my virtual infrastructure. And that's the Excel file, which I will be also saving. So let us failover. We move, and I will just click Ctrl S few times. Okay, so now we see there is something stopped. So the saving Excel takes time because the system is temporarily unavailable. The loop was stopping, the copying file is not moving, right? So failover takes a few seconds, and once a failover is completed, I will have everything running again, right? Okay, so still failover is not completed, but it is already moving. So I see the loop is moving, copying started, and my save, of course, is saved. So I can save one more time on the menu to show you that it works. Okay, so I was changing the content, right? So everything works fine, and everything now is active on the second node. So that's my second node. And of course ESX is running just as usual. There is no problem at all, right? Okay. So that was failover, that our pool was switching from node 32 to node 42. We can of course switch it back. While switching back, then of course we will okay. So we see that everything is not working now. If I will try to save now, then of course it is not saving at this moment. Okay, so now everything works. So that was the iExcel and save one more time. So everything works super. My copying is working again, and my loop, script loop, which is writing to MS SQL, which is running on the VMware, is working as well. So it's quite okay. I could maybe also reboot power off, but we want to finish our webinar quick. So I will not demonstrate this time. I will just now switch to the duplication. So how to check the duplication? The scrap is a very nice tool, because when I run the scrap, it will be showing exactly how much data on the pool I need to read to check consistency. Okay, so scrap was starting, and I can stop it anytime just to have an idea how much scrap is finding data on the pool. So at this moment it is finding 427 gigabyte of data, right? So what happened when I will delete this? So I stop the batch, then we go here, and okay, we can delete this. The volume is set for the duplication, right? So this data exists in the first directory. It was deleted, but it was duplicated. So now when I run the scrap, after deleting the duplicated volume, the number of data on the pool is the same, right? So it didn't give us any free space, because I was just deleting one-to-one duplicated data, right? Of course, when I'm doing the duplication, the space is not growing, and when I'm removing this duplicated data, I'm not having more space, right? I will have only difference from the user point of view, right? But not on the pool, okay? And now I want to simulate, yes, I want to see how the data is growing, so I need to switch the duplication off. So that's nice that you can switch the duplication on and off anytime in production. So let us edit the data set, and I will switch off to disabled. Okay, so now the duplication is disabled, and let us run this batch. Okay, so now you see I was taken also one bigger file, 2.7 giga, that we will be able to see the difference quite easy or quite fast. So now I was copying some new data already with the duplication switch off. So let us run. Oh, we have 429 already. So there is a difference. Okay, so I can stop it. So we prove that when we were copying this new data without the duplication, then the scrap is showing more space. And of course this is expected, because we have duplicated data, right? So what happened when I will again delete this, and I'll delete. Okay, so let us physically delete it. Sorry. Okay, now we will switch the duplication on again. Okay. Okay, and then we can try to run our batch one more time. Now we are copying new data, but of course the data is one-to-one duplicated, so we could check it now. We have back to 427, right? Because the data was deleted, and now when I'm copying new duplicated data, the pool will be not growing anymore. So on the NAS, because the SMB is sending data on the native blocks of the storage, so the storage is receiving the blocks and then doing this 128K by default. If the file is smaller, okay, let me see. If the file is smaller, then the smaller block will be used, but this will be very seldom the case. So when I go to edit data set, we will have the default. There is no even information about default block, because the this is fixed, it's not changeable. Dynamically, ZFS will create the smaller blocks if the files are smaller than 128K. In case of ZFS, in case of iSCSI, this is a big difference, and this can be tricky. You need to go to the help and just fresh release node, so UP18. And in UP18 we have added the comment because it was unclear how the duplication works when iSCSI is used. So we have added this information that in case of using iSCSI and, for example, Windows NTFS, the best option here will be using 64K format on NTFS, and the iSCSI block 64K as well. In case of iSCSI, you can define the block size. Let me switch to Jovian. Okay, so iSCSI, when we go to the volume, okay, so we can see that the edit, the block size is defined for 128K. If you are using iSCSI for NTFS and the duplication, please do 64, and please do choose the format of the NTFS 64. In such case, you will have the best combination, because every block by format will be sent by 64K, and Jovian will also store 64K. Why? The problem will be when you will use 128 on the volume size and the, let's say, default 4K block size format from Windows, because in this case that will be plenty different alignments, and the system will not find duplicates, so the duplicates will be almost not working. If you will have, let's say, 64K on Windows and 128K on the Jovian, then there will be only two options. So the first duplicated copy will not work, and every next one will work, because both options will be already existing on the pool and the duplicates will be found. So that's why we discuss this for the iSCSI. So iSCSI can be tricky. Make sure that in iSCSI both sides are equal. So your client format size and the block size on iSCSI is equal, then you will have the best. Of course, you need to get as big as possible block size, because on the smaller block size, for every block you need hash, you need a checksum, so that the duplication table will be much bigger, so much more resources will be needed. So always you need to create the maximum possible block size for the duplication. Okay, so I hope that was the good demo for the just we can on the rest we can make the failover one more time, show it one more time how it works. So I have Excel, I have MS SQL, right, and I'm trying one more failover, right? So good, it is failing over, so I'm trying to save. my Excel all the time, and of course now when the failover starts, okay, then we see that both actually three of them, Excel is waiting for access, copy is waiting for access, and my MS SQL is waiting for access because of the failover. Same will be on the ESX side. When I will just refresh, I will need to wait until my storage is coming back, right? So now it's back, okay? So MS SQL works, and the copy works, and my Excel works as well, okay? So that was the unified storage. I could add NFS as well, right? So we have a Sun, iSCSI, SMB, and NFS will work as well at the same time. Of course, we will need to define the volume which is exported by NFS. When I go to the second node, we could just in shares, or this share could be also parallel mounted by NFS. If we go to the edit and the protocols, we could also enable NFS service here as well, right? And then mount by NFS, and it will be working as well. So that's the unified storage, high availability for NFS, iSCSI, and SMB. SMB or CIFS, because you can have SMB 2, 3, and SMB 1, that's equal to CIFS. If you will consider the fiber channel, then soon we'll be working also on adding fiber channel to this as well. So I'm done for today for the setup. If you have any questions, I will be available after stopping recording, so we can chat. And for now, I will just stop the recording, and I just want to invite you for the next webinar, which is coming soon. Okay.